Yes, we're going to be talking about free falling today. And welcome back, everybody. Hope you had a good day yesterday. I got to adjust a couple things on the magic screen here. All right, so today I have my bowling ball, a feather, a ping pong ball, and a hammer. We will be dropping some things. I wish we could drop them in school, make a lot of noise, drop them off the bleachers, but we're stuck here down in the basement. So today, how do we get into free fall? Where do these ideas come from? Well, Galileo Galilei, you know Galileo, from the Queen song. But there's Galileo Galilei, lived around 1600, called the father of modern physics because he was one of the first guys to do experimentation. Tried to not just come up with ideas, but also try to prove them through experiments. His big idea that we're going to talk about today is that objects of different masses will fall at the same rate when near a large body. So two very different objects with two very different masses will fall at the same rate. Well, if I take a hammer and a feather, obviously the hammer's going to fall a lot faster than the little feather. Feather's going to float down, right? The hammer's going to drop pretty quickly. Now, not sure what that flicker was, but he's neglecting air resistance, okay? And that's what we're dealing with today is free fall. Free fall is, a second, everything's rolling off the table. Down to the bottom there, free fall, when the only force acting on an object is gravity, okay? So you're neglecting air resistance and all other forces that might affect how an object falls. So is a skydiver truly in free fall? They say they are. No, they're not, okay? Because there's air resistance when you're falling, okay? So we're talking about a vacuum, okay? And the best place to find a vacuum is in space. Obviously, Galileo couldn't go to space, so he had other ways to prove his ideas. We're not going to get into that today, but one thing he did not do is throw things off the Tower of Pisa. That's a common misconception that the Leaning Tower there, he was a professor at the University of Pisa in Italy, home of the Leaning Tower of Pisa. He did not throw objects off the Leaning Tower. He had other ways to test his methods, but what he found out and what he actually calculated pretty close to what is accurate is that when an object is in free fall near Earth, they will accelerate at a constant rate of 9.8 meters per second every second. Okay, and that's what this. That's a big finger right there. Wow, 9.8 meters per second. It's right here. Every second something is falling in a vacuum. Okay, in a vacuum. Now, bowling ball will get pretty close to that, or heavy steel balls, which is what Galileo used to test his ideas, because they're very heavy, like the bowling ball I have. They're very aerodynamic, so they cut through the air pretty easily. He didn't have the ability to create a vacuum or go up into space where there is a vacuum, but he was able to actually calculate pretty close to what is true now, is that 9.8 meters per second is the acceleration due to gravity. Okay, so every second that it's falling, you can see that this ball that this girl's dropping is traveling a farther distance after every second. It's accelerating, okay? After 1 second, 2 seconds, 3 seconds, gone farther, 4 seconds, gone even farther, 5 seconds farther. It's accelerating at a constant rate of 9.8 meters per second, okay? In a vacuum. All right, so where do we go from here? if I take an object such as a hammer and a feather and drop them on Earth, obviously the feather's going to not drop as fast as the hammer. Okay, but if I were to create a vacuum, okay, like in space, and one of the first videos you're going to see is a vacuum in space on the moon. There's less gravity. Things will fall about 6 times slower on the moon, but it is a vacuum. There's no air resistance. So you'll see that experiment done to prove Galileo was correct. Or I can take a bowling ball and a feather and drop them. Probably woke up the kids. Obviously, the bowling ball is going to drop a lot faster on Earth than the feather because of air resistance. But if I drop them in a vacuum, which the second video was really a cool video, they create a vacuum and drop a bowling ball and feathers to prove this. Pretty cool video. That would simulate free fall. The third place you could simulate free fall is in a plane called the Vomit Comet, and you'll see a video on that. The Vomit Comet is an airplane that is used for astronaut training, test pilot training, fighter pilot training. It goes high, like on these mountains back here, and climbs, then dives down in a steep dive that matches Earth's gravitational pull, that 9.8 meters per second in a steep dive. Everything in the plane, the air inside the plane, the people inside the plane, any objects that are inside the plane are also falling at 9.8 meters per second. They're accelerating at that speed as they're in a steep dive for about 20 to 30 seconds. Then they climb back up and do it over again. And everything in there simulates free fall. The plane itself is not in free fall because it's traveling through the air, but everything in the plane is falling as if it's in a vacuum. It's falling at the same rate that everything else would fall in a vacuum. So there's some neat things that they do inside there. They call it the Vomit Comet because if you've ever been on the power tower, right, where all of a sudden it drops out from under you, and you get that queasy, sick feeling in your stomach, or if you're in a car going over hills, and all of a sudden you feel that queasy feeling in your stomach. That's what it feels like over and over and over inside the plane as you're diving. So people do vomit, so they call it the Vomit Comet. So you'll see 3 videos today that demonstrate free fall. Again, free fall, back to good old Galileo up here, is when the only force acting on an object is gravity, okay, pulling it down. So no air resistance, we're neglecting air resistance, and I hope you enjoy the videos. I think they're pretty interesting. And then tomorrow we will get into the next topic, terminal velocity and air resistance. So today we're going to neglect air resistance and just talk about free fall. All right, so enjoy the show.